Hello, everyone. Welcome, Vinicius, Nuno, and Leandro. We are back here at the Azure channel. We have one super special video about Windows containers, and the special guest is Vinicius Apolinario. Vinicius is in Seattle, and Leandro and myself, we are here in Australia, Nuno in Switzerland. We have all the continents covered on this call. And yeah, welcome, guys.
Hey, folks.
Hey,
Hi, everyone.
thanks for having me.
Thanks, Leandro. Leandro is like he and Vinicius as well. The first time here on the channel. If you don't know the Azure channel, subscribe, hit the button. There's a few videos. Nuno is like a superstar here on the channel. And we're just talking that there's like a Rancher desktop video with Nuno. But today we're going to talk about Windows containers. And Vinicius, is all yours. Tell me what you have for eyes and welcome.
Well, first of all, thanks for having me here on the show. It's always a pleasure to be talking with you folks, and I feel like I have good buddies on this show that know probably more than me. So it's a pleasure to be here, first of all. The idea today is to talk about Windows containers, so maybe let's dive right in that content.
Just tell me
So
who you are.
Yeah, exactly. Let me introduce myself first. So I'm Vinicius. I'm a fellow Brazilian, just like Jorge and Leandro. I work as a cloud advocate at Microsoft, focusing on containers and Kubernetes for the IT Pro and operations audience. And before this, I was part of the Windows container product team. So I was working on the team that actually developed Windows containers for our customers. So maybe let's dive into what Windows containers are. And for those of you that are not familiar with containers and don't know what the containers technology is, I want to talk about a scenario and see how many of you have been in that situation earlier. So if you've been in operations or if you've been in development, either side, it happens a lot that when you develop an application, you test the application in your machine and you package all the prerequisites of the application. And then when you move from your testing environment to a production environment, the application doesn't necessarily work exactly the same way. So if you've been in that situation before, you're probably it's probably a good idea to listen about and learn about containers. So containers, they solve a fundamental problem of packaging an application and then making that application behave exactly the same way, regardless on where you run. If you're running in your machine, if you're running in your testing environment, if you're running in a production environment, the container itself is going to behave exactly the same way. From an architecture perspective, if you think about a VM or a virtual machine, a VM is basically the virtualization from the hardware up. The container is the virtualization from the OS and up. And what that means is that you have isolation between all the containers in a VM or in a physical server, but then you don't have another OS, just like in a VM. Every time you deploy a VM, you have a full OS there with a full kernel that you have to patch, you have to update, you have to maintain. With a container, you have to maintain only one operating system for all the containers you have running, but then you have the isolation between the containers. Now, when we go into more details, there's like Hyper-V containers and process isolated containers that don't necessarily, it is important at this point for you to understand what containers are. It's a way for you to package your application and make your application behave exactly the same way, regardless on where you deploy. I encourage you to learn more about Windows containers and its architecture. So we have a link at aka.ms/containers. All the documentation about Windows containers are there. With that said, for today, what we wanted to talk about is what are the top 5 reasons that customers should think about for moving their IIS, their Internet Information Services workloads or the web workloads on Windows Server into Windows containers. So it's more like you probably have a web server running or a web server that you maintain that is sitting on the corner and you're not necessarily paying a lot of attention, but then why should you move that web server that is working today into Windows containers? So we talk a lot about the process of moving, but we don't talk about why you should move. So that's what I wanted to discuss today. So let's start with the
Vinicius.
first. I'm sorry. Yeah, go ahead.
Just before we start, Leandro, you want to make that question? You just asked me about is that the question? Is container just Linux?
Oh,
Yeah, that's a good one. I think most of the customers, when they look at container, the first option is Linux containers. And that seems to be a trend that people don't even realize sometimes that there is a Windows option. So I just wanted to hear your thoughts on whether you choose Linux or Windows and why Windows.
yeah. You're absolutely right. The majority of the market for containers today is Linux, and it's a simple reason. It started with the Linux. Linux was the first option for customers that wanted that flexibility for containers. Windows came later in that party. Windows containers started in Windows Server 2016, so we are in the third major release of Windows Server after Windows Server 2016, so we are in Windows Server 2022. And Windows containers is a more well-established technology in the market, and we have a lot of customers using. But more important than that, why should customers consider Windows containers and not Linux containers? Because let's be honest, there are there's not feature parity between Windows containers and Linux containers. We know that the ecosystem has evolved way more around Linux containers than Windows containers. And I have two main reasons that when I talk to a customer, I talk about those two reasons. The first one is you might have applications that only work on Windows, right? So if you have a .NET framework based application, you have to re-architect your application from .NET Framework to .NET Core, or today is only .NET, the naming convention, but you have to re-architect the application, which involves a developer going there and modifying the application for the new framework, right? If you don't want to go through that process, your option is to stay in .NET Framework, but move the application to the new platform where you can run on Kubernetes and containers, right? And you can only do that with Windows. So it's not just .NET Framework, any other re-architecture of the framework that you want to use, regardless if it's Microsoft or not, if it was made for Windows, you can probably only run on Windows if you move to the containers space. So that in itself, it's one big reason. And the other reason is we have a lot of Windows shops out there or Microsoft shops out there, right? And it comes to support. Like if you want to have a centralized place for support, that's Microsoft, right? So you are running on Azure, you have Windows workloads today. Moving to Windows containers is another alternative for you to maintain a one centralized place for support. So if you have a problem with the Windows container platform, you're going to call Microsoft, and Microsoft can take care from the framework, the operating system, up to the lower levels where your container is running.
Yeah,
I mean, feel free to add, folks. You probably know.
Yeah, I
a
can
lot of other reasons as well.
definitely vouch for the second one. So I used to work in a pharma, and it was a Windows shop, like no Linux at all. And just to expand a little bit more, the point or the question, it was like also these Windows shops sometimes they don't even know that containers are possible.
Mm-hmm.
Right? They don't even think about like Linux. Like Leandro said, it's like, oh, container equals Linux. So I don't even ask, is there a possibility of having those containers, this technology on my Windows? So no, it's totally relate there.
And I like the first
Yeah.
point as well, the lift and shift approach. I just want to migrate. So I don't want to redevelop the application. Most of the time, the developer is already dead. No one knows where the developer is. There is no documentation. It's an old website. So yeah, I like that approach.
Yeah, and beauty on top of that, like it allows for operations and IT pros to actually perform the migration or the modernization process, right? So you don't necessarily need to touch the code of the application in order to move to Windows containers. You can keep the application as is and then move the application to Windows containers.
And as a follow-up from that question, I saw a post from you a couple of weeks ago where you say that Forza runs on Windows containers.
Yep.
Is that correct? Do you have any other success story and any good examples to tell customers, oh, okay, didn't know that they were running that in Windows containers before?
Yeah, we had a few over the years. The very first one that was a big one that people like to know about was Alaska. So part of their website for promotions was based on Windows containers, just because the application that they had was already on .NET Framework, right? And then they kept the framework, but then moved to Windows containers so they could scale up, scale down way quicker, because containers are smaller than virtual machines. So then you can run a promotion, for example, and scale up and down as you need. Forza 5 was launched as Windows containers on AKS, or Azure Kubernetes Service. And basically, their thought process was exactly the same. They had to move away from cloud services, the old cloud services on Azure, where they had their Windows application running. And they had to move, so their option was re-architect the application to Linux and then learn about containers and Kubernetes, or keep it on Windows and learn about Kubernetes and containers. So they chose the second path, which is much simpler, right? It doesn't, and that's another point, like there's nothing preventing the customer or even like Forza 5 to move to Linux. Now that they are in AKS, they could even go further and take advantage of other things maybe on the Linux platform, but the first step to move to containers and learn about the technology and the platform was easier because they didn't have to re-architect the application. So if something goes wrong, is it because it's on containers? Is it because it's on Kubernetes, or is it because we moved to Linux, right? So you eliminate complexity when you move without modernizing or re-architecting the application itself.
And you have a very stable product for years, then even any small change, yeah, you can introduce bugs. Like I'm probably not sure you guys, but I'm a developer, background, and it's kind of even a small change you can introduce like a new bug.
Yeah.
And I think it's a right decision for many products still. And people say, well, it's just for legacy. It's not just for legacy. Once you now have like a AKS cluster with Windows nodes, you can keep using Windows nodes for other things as well.
Yeah.
I think the future will be this mix between Linux nodes, Windows nodes, and even ARM64 nodes as well.
Yeah.
And that's okay.
Yeah.
That's great. I think you're going to talk about the use case when you show your migration.
Yeah. So going back to the like, what are the 5 reasons that customers should consider for moving their IIS workloads into Windows containers? So the first one, I'll do a lot of this. Can you relate to this issue? And the first issue is end of support, right? Most customers, when we go to an audience, like an event or Ignite or something like that, we ask the question, how many of you have Windows Server 2003 running in your environment? And then we see a couple hands. And then how many of you have 2008 still running? And then a couple hands. And then 2012, and then a lot of hands go up. And 2016, a lot of hands go up. And there you go. But the point is, end of support happens every 10 years. So 2008, of course, out of support. The next one is 2012. And guess what? Like, I came to that realization a few days ago. 2016 is already out of mainstream support. So what that means is that Windows Server 2016 is not getting new feature updates. It's getting security updates, which is good, but you're not going to get any new features on Windows Server 2016, right? 2019 is there, but like at some point, end of support is going to hit you. And it becomes a problem for customers because they have such a vast amount of servers running legacy applications that the process of migrating from 2008 to 2012, for example, takes them a few years to actually finalize the process of migrating all the servers. And by the time that they finished, the team that did the migration, they have to start all over again because the next end of support is already there. So one of the things that containers makes way easier is to migrate from one version to the next. Containers are based on what we call a Docker file that basically describes how you deploy your application. So you have a prescribed way to deploy the application inside of a Docker file. And basically what you do is you use a build process to read the file and perform each one of the actions that you put in there and build a container image. And that container image is the asset that I mentioned before that you can move between environments and is going to perform exactly the same way. Changing from one version of the operating system to the next on a container is as simple as changing one of those lines. So the very first line in a Docker file traditionally is a from statement where you say, I want to start building my container image from another image. And then you have images based on 2016, 2019, and 2022. My application is there to be deployed on that container image. So if I change from 2016 to 2019 on that Docker file, all I have to do is build the image again. Of course, you have to test and you have to validate if the application runs. But the process of migrating my applications in a series of migration is so much easier to do in Windows Server. In Windows containers. Containers overall, I would say, but then end of support is one of the issues that customers face because they have to migrate all of the applications that they have. If you decide to move to Windows containers, end of support is probably not a problem for you anymore because then you can move from one version to the next in a much simpler way.
So that's a very important point, and here is more like, I don't want to enter too much into like how containers works or anything, but just like to avoid these IDs, these received IDs, right? So whenever you do a lift and shift, like the first phase is normally you do a one-to-one, right? A one-to-one migration. So right now, can we run like, let's say that I have like a host and there's the container, right? So there's a link here between them. But can I run like my first container, migrated container, let's say 2008 or 2012, on a host that will be 2019 or 2022, for example? So the container, I create a container that the base OS will be 2008, for example, and then I'm running it on my host that is running 2019. Is that feasible nowadays? Yeah.
Mm-hmm. Because I get your question. So there's a few notes about versioning on Windows containers. In Linux, this happened less, but basically the issue is on a VM, if you have a host, the VM is completely independent from the host, right? You have a virtualized hardware that once you give to the VM, you can't claim it back. Like there's options for claiming memory and processor back, but essentially you're giving that to the VM, right? And the VM is gonna bring up a new kernel, a new OS, everything's for the VM. With a container, it's not exactly like that. They are sharing the same kernel, right? So even on Linux, there are some limitations on if you move too far away from the versions of the container or the host OS, you're gonna see some issues. But on Windows, this is much more explicit. Like we don't support different versions of the OS between the host and the container. So if your host is 2016, your containers are going to be 2016. If your host is 2019, your container is going to be 2019. So yes, you have to upgrade the host as well. However, in most environments, you usually have a orchestrator that can help you with the process of migrating the host. And ideally, you're not running anything else on the host other than the containers itself and other management software, right? So upgrading the host is easier because of the orchestrator. And upgrading the container is easier because it's just a statement that you have in your Docker file, and then you just have to redeploy the pods or containers that you have in for your application running. Now, again, Windows containers don't require that you have the same version between container host and container OS itself.
Okay. Perfect. Just like I know it's maybe a small limitation, but it's something that will help actually plan for the migration of the applications later on. And that's the strength of the containers, like you were explaining. Is like once, I mean, your host is part anyway, the upgrade of your host should be already part of your infrastructure way, so you don't change anything here, right? And then your applications now, instead of doing like installing how many hosts, test your application, ensure that the library is correct or not, you don't know, and maybe mess up with another application that you are testing. Now you have this isolation, and that's where containers actually, and Windows containers will like really help you in that migration.
Yeah.
Okay, great.
Absolutely. All right, so that's just one of the benefits. Benefit number 2, abstraction layers. And this comes more to the orchestrator. So let me explain a little bit about container orchestrators first. So I mentioned that containers are smaller, that are easy to manage. Another aspect of Windows containers, or containers overall actually, is that they allow for scale much faster. And I mentioned that before. And one of the reasons I'm going to talk, one of the benefits I'm going to talk about is horizontal scale. But before I get to that, it so happens that when you start using containers, one of the things that you realize is that you have multiple containers and you need to manage them as one single application, right? So you have to think about high availability, you have to think about load balancing, you have to think about many other aspects that a container orchestrator can help. And there are many container orchestrators or flavors in the market. The most famous ones are Docker Swarm and Kubernetes, right? Essentially, they serve the same purpose, which is managing the life cycle of containerized applications and container hosts, so you can manage them as one with high availability, load balancing, updates, placement of containers, and so on. With that said, another benefit of using container orchestrators is the abstraction layer. So think about your IIS environment. You probably have a web config file in your deployment of IIS that says, this is the database connection, this is the username, and this is the password to get to that database, right? And if something changes, if you want to move your application from on-premises to the cloud, or if you want to upgrade your database version, or if you want to, maybe there's another kind of abstraction that you need for the application to another service. When all those things change, you have to go instance by instance, changing those configurations. With container orchestration, one of the things you have is you have abstraction layers, so you don't have parameters for database connection and secrets like username and password tied to the application itself. That has 2 benefits. The first one is if you're scaling up and down, you have one centralized place for those configurations, either connections or secrets. The other thing is, let's say, as I mentioned before, you moved your database from a SQL server to SQL on Azure. You changed the connection. You probably changed the username and password. You don't have to go and change your instances for IIS. With the abstraction layers, all you have to do is change the configuration once, and all the instances will now have the configuration to be used by the orchestration layer. With Kubernetes, specifically, you have secrets, for example, that you can store as part of your Kubernetes configuration, and then the application use that secret. And you have other configurations like configuration map used, for example, for database connections that you can remove from the instance itself and put it in a centralized place. So if you change the connection, just change the configuration map, and all the applications are going to get that new configuration moving forward.
And Vinicius, you talk about this like IaaS. To have multiple instances, you need like a web farm. I don't even remember that anymore. I think I forgot.
That's true. Yeah.
It's not that easy to create like a web farm, and then even like you have 3 nodes with IaaS, you need a web farm, you need to synchronize, and the deployments is like you said, you have to do one by one, and it's a nightmare. It's not like a simple task as a Kubernetes cluster. If you have IaaS like a single instance, that's another thing, maybe moving to like a fully managed service it'd be easier. Like in Azure, you can do Azure App Service or something, but even using Windows containers. But when you need to scale multiple instances, doing VMs is compare like orchestrator with web farm is a big difference.
Yeah, absolutely. And that's one of the reasons why I put as the second reason to think about containers, because with containers and containers orchestrator, you get the ability to start removing specific configurations from the instance, and you abstract them from the compute itself, right? So the instance of IaaS now operates as a web server itself. So all the other things that you are gonna have for specific scaling methods, they are outside of the instance of IaaS itself.
Yeah, exactly. And then I think what happened a lot I see with customers is, well, they used to have this application and the companies keep, growing. And now like a single instance, even if they get the biggest VM in memory, is not enough. Now they have to scale out, and they have these pain points. They have to fix the session, they have to fix the caching, they have to remove all the local files from the instance, put in some like blob storage. Once they fix all these things, they can, but they still a problem with the scaling out.
Yeah.
And that's where I think we're talking about here. We can have a solution for that.
Yeah. The more you can abstract from the instance itself, it's better for management. Yeah. All right. So talking about abstracting things away from the instance, reason number 3 the customer should be considering for moving to Windows containers, SSL certificates lifecycle management. And if you ever had to renew certificates in a web farm, this is going to come in handy, because SSL certificates in IaaS are basically deployed per instance. Granted, there's a feature nowadays on IaaS that I know you can provide a SMB path that you can use on multiple nodes. So that helps a lot, by the way. But still, it doesn't manage the life cycle of the SSL certificate. It only gives you an option for the IaaS instance to look at the centralized location for SSL certificates, right? So what is different for containers? So with containers, one of the things that we have in containers orchestration as well is you can abstract part of the networking from the IaaS instance or the windows in the IaaS instance to the orchestrator itself. So you have something called, in Kubernetes, for example, ingress controller that basically handles the SSL connection between your clients and your web server, right? One of the things you can do is you can use a separate service. In Azure, we have Azure Key Vault that manages secrets, multiple types of secrets. For example, you can manage usernames and passwords, for example, that we just talked. But the other thing that Azure Key Vault manages is SSL certificates. So first of all, the IaaS instance doesn't care about HTTPS anymore. It's just regular HTTP because it's behind your ingress controller. You can have a HTTPS if you want and if you need because of compliance reasons. But the main thing is the certificate that your clients are viewing are managed by the ingress controller, and that, or the connection, I should say, and then the certificate lives in Azure Key Vault. And Azure Key Vault manages the whole life cycle of your SSL certificate if you want. You get email notifications when your certificate is about to expire. You can auto-renew certificates, and then all your IIS instance, they sit behind the Ingress controller, abstracting away not only database connections, usernames and passwords, but also SSL certificates.
That's a good point. I think all of us have faced that before, where you forgot to renew a certificate or something's down because someone forgot to get the new certificate. And having the example with Key Vault where you can just set and forget, it's really, really catchy.
Yep.
I would say.
Yep.
And
All
you
right.
could break the whole web farm before if you do some mistake, make some mistake there.
Oh yeah,
all
that's
the
true.
communication between the nodes.
Yep. Reason number 4. Moving your IIS instance to Windows containers is your first step into microservices. Now let me explain this one. Most customers, they have IIS farms, and then they have multiple websites deployed on those IIS servers. And IIS has a mechanism called application pools to isolate workloads from each other, but they are essentially on the same kernel, on the same instance, and so on, right? One of the options that you have when you move your websites to Windows containers is because Windows containers, they use so much less resources. You can have pretty much an application pool or website per container. When you start to do that, you start to isolate your workloads more and more, and you start to take the first steps into microservices. So what's the benefit of that? If you have to upgrade versions of .NET, or if you have to upgrade applications in an isolated way, moving from single website with multiple app pools to microservices with multiple containers per service allows you the flexibility to change configurations on specific websites, regardless of the other websites, right? The other benefit of that is you can start looking into DevOps a little bit more. So practices of DevOps using CI/CD pipelines, they apply much better when the services are isolated from each other versus when they are running as a monolithic thing where you update one, you update everything. So imagine doing a OS update, for example, for a web farm where multiple websites are sitting on the same server. You have more workloads on that server to be updated, and then versus single containers for each of the services that you have much more flexibility in terms of update, upgrade, and everything else.
Actually, that's about the going from one point where you have like everything centralized to these microservices mindset kind of. It's always like coming from, let's say, the IT ops side of things. Sometimes it's the most difficult part to say like, okay, how I split them. Now, there's some legends when Windows containers started about sizes. There's a trade-off, of course, like containers are not for free. It has a size nowadays. So how are we with Windows containers? Like, because your idea, which is great, by splitting the application pool into single application containers, let's say, I'll call it like that. It's okay. It's great. Like you can manage, you can scale it up, and you will speak about it afterwards. But what will be the price in terms of size of the container? Is there something that we need to plan in advance, or are we, let's say, are the sizes quite down nowadays? And by down, I would say between like the 500 to 1 gig to maybe 2 gigs size containers.
Yeah. So that's a great question, and it's when people start to look at containers, Windows containers for the first time, is probably one of the main things that they realize. And we get a lot of questions around size of Windows containers. And when we say size, we're talking about the size of the image. So one of the things that containers they differ from virtual machines is that when you run a container, you base your image on other images. So you at least start with a base image from Microsoft for server core or nano server or server or the Windows image. So I'm going to briefly explain what those images are. So starting with the smallest one, nano server. Nano server is a base container image that was created based on the nano server installation option, right? It's extremely small. It's like 200 megs for a Windows instance, right? However, we only achieve that size of container image by removing a lot of stuff from the operating system, right? So most of the APIs that you expect in a Windows system are not present on the nano server. Nano server, the application has to be written by a developer targeting nano server or the nano server's APIs, right? It's only used for new applications. If you have an application running today, it's not going to work on nano server. IIS is not present on nano server, right? So if you have a .NET application, it's going to be using Castro, and the application was written for the .NET. I was going to say .NET framework, .NET itself, not .NET framework, right? .NET framework, by the way, is not present on nano server. So the next image is server core. And server core is about 5 gigs in size these days. The other thing that I can talk about is how we update the images, because this makes the image smaller or larger depending on the time of the year. But for now, let's just keep the around 5 gigs in size. And server core is based on the server core installation option for Windows. So most of the APIs that you expect on Windows Server in the server rows are present in server core, right? You can run .NET Framework, you can run .NET, the new one, .NET Core. You can run other applications like Node.js and so on. And more importantly, MSI is present on the server core image. So that means that if you have an MSI package, you can deploy that package in server core, right? However, it's still server core. So if application doesn't work on server core, it requires, for example, use of the GPU. Server core has no APIs for accessing the GPU, right? So if your application requires GPU access, we have another image, which is much larger, probably around 10 gigs in size, called server. That image is based on the installation of Windows Server with desktop experience, but no containers have UI. So the UI is not there, but the installation itself is based on the server with desktop experience. That's like 10 gigs in size. When people look at that, compared to Linux containers, which are usually less than 100 megs, right? And they go like, well, why would I choose to use a container that has 5 gigs in size, right? And my response to that is, it's better than a VM. Remember that we're talking about an application that cannot move to Linux, right? So it's still better than a VM that you move to Windows containers and abandon the VM, because the VM is even larger than that, not just from a disk footprint standpoint, but from consumption of memory, consumption of CPU, all the work, the overhead of managing the OS and everything else. So moving to Windows containers for your IIS workloads is still better than running on a VM. Now, we're talking about applications that cannot be converted to Linux, or applications that the developer is not around anymore, as Leandro was saying. Hopefully, the developer is alive, just not around anymore. But yeah, so that's my response. Like, you should not be comparing Windows containers necessarily against Linux. You should be comparing Windows containers to a VM.
No, totally, and that's why I was saying like I didn't even mention Linux, and Linux, like the footprint, the initial footprint is great. Like if you take an Alpine, it's like 50 megs, I think, or something like that. But then it's Alpine containerized, so you need to add potentially a lot of libraries and packages to run your application at the end of the day. And suddenly, if you look at the size of your container, you are far from the 50 megs. But that's another discussion. That's why I didn't want to compare you. Your point was great because you are comparing like what is comparable, and it's like VMs versus containers on Windows. Okay, let's keep. So one mindset then it's like to say, correct me if I'm wrong, but it's like we are getting, let's say, an abstraction less as VMs. I mean, you can run containers on VMs. That's not an issue. But here is like, instead of having your host VMs application, now you have your host containers application. And that's the size, that's the, let's say, the resources footprint that you will gain at the end of the day. Of course, if you stack what you had already, then it will be 5 giga more. But now if you rethink a little bit, then it's like 20 giga less.
Yep, exactly. Yeah, that's a very good point. Because you can reutilize a lot of resources in terms of CPU, memory, and disk, you can pack a lot of containers in less hosts than you would if you were running on a VM.
Yeah, and Vinicius is not just the storage; they're using less memory as well. Like if you get a server core and you boot, how much memory you need to boot like a Windows server, like VM? On container, it'll be like 200 megabytes or something, 300 megabytes in a server core. And another option is the Nano server is also an option for .NET Core. If you don't want to have, if you don't have knowledge on Linux and don't want to manage the Linux nodes, yes, you can mix your full .NET framework, migrate to server core, then moving to microservice, but you don't have to move to Linux. You can keep next to your server core, and run as a Nano server. Means that you can run a Nano server container inside the server core host.
And that's another point, not part of the 5 reasons here, but as a professional that you should think about. If you have knowledge on managing and troubleshooting Windows environments, then moving to Windows containers, you can leverage a lot of the knowledge. You can leverage a lot of the knowledge you already have, right? So troubleshooting Windows containers is like opening remote PowerShell sessions, looking at event viewer logs. You can do all of that with Windows containers as well, right? So a lot of the knowledge you acquired over the years by managing Windows instances, you can leverage on Windows containers as well.
Yeah, that's a very important point here. It's like, it's not starting from scratch. You are basing like your knowledge of running an infrastructure. And I'm ops at heart, right? I'm not a dev. I'm not like Jorge. I'm an ops guy. I came from ops side.
I'm ops as well. I guess the developer here is Jorge.
But the thing
George.
is,
Like
the
I'm
thing is
doing
like when virtualization came, for example, you had to rethink a little bit how it was working. Like, what are the resources? What was a virtual disk, a virtual network, virtual switches, and everything, right? I'm talking early 2000 for the ones who were born. I'm not like Leandro. I think about the ones that were not born and not died. No, but the thing is, like, it's really important. Containers, you can learn containers. There's a curve, definitively, right? But your ops knowledge and even your dev knowledge is not to be like, okay, I have to rethink it fully. No, you don't have to do that. That's a very important point.
And I mean, like a .NET Core running on Nano server is pretty fast. It's like 50 megabytes, memory. It'll be like very similar to like a Windows Linux container. It'll be performing. Then if you are a young generation there watching this, just like, don't be afraid. You can run very lightweight Windows containers. And there are even a few videos here on the Azure Task channel showing that. I was showing comparing memory and all these things. And yeah, rest assured that you'll be fine. It's not legacy. It works fine. And And one thing we have discussed, Vinicius, is the Windows 2016 onward is completely different from before. The Windows
Yes.
2016 was rewritten from scratch. And people say, containers is Linux because, Linux is all based on files. And now you can create like an image, like a VM template, an image, like what you call Docker image, based in files. But Windows 2016 did that. We have registry, you have everything there. The time that you change something in your container, you can save that as an image.
Yeah.
And we pretty much capture all the files, registry. And 2012, yes, was different, but from 2016 is completely different.
Yeah. The way Linux containers and Windows containers operate from an architecture standpoint is very, very similar. So yeah. All right, let me go to the reason number 5 and final, but no, as important as the other ones, which is horizontal scale. And what that means is, how do you support increase the number of requests for your website? Right. So I think all of us have been through the process of like, you're trying to buy a ticket for a concert online or something, and then the service is out, or they have a queue for people waiting in line, virtual queue, and it all comes down to what is the capacity that you have available to support the amount of users that you have requesting your website, right? And of course, I'm not going to comment on if you're running on premises or if you're running in the cloud. I'm just saying, if you decide to scale horizontally, which means more instances providing supporting your environment, it's an issue just because you need to scale that in a way that all of the instances inside your environment are going to behave exactly the same way. And because of all the overhead of managing IaaS instances one by one in a web form, then it becomes a problem for horizontal scale. Aside from the fact as well that VMs, you have the entire VM to boot, you have another OS to manage and everything else. So what does horizontal scale on containers look like? Well, first of all, from the steps before, we abstracted away everything that you might have that is unique for the instance, for the IaaS instance. So there's no certificates in there, there's no database connections or secrets that are specific to that application. There's other stuff that you have to think about as well when you move, like for example, if your application uses some kind of local folder, you can provide, for example, persistent storage to containers that is centralized for all the instances of containers. So the point is, you removed all the aspects of uniqueness of each of the instances, right? So if you bring a new instance for your website, it's going to behave exactly like the existing ones. So when you have a load balancer, for example, it doesn't matter to which instance it goes. All the instances are the same. Now, services like Azure Kubernetes Service, they can provide not only horizontal scale, but auto scale. What that means is, if you have 10 instances for your application and it's supporting, it's just fine. And then your CEO goes and gives an interview on TV, and all of a sudden you have like 1,000 more users accessing your website, or hundreds of thousands of users accessing your website all of a sudden. Well, guess what? AKS can see that influx of traffic, scale up for your application, bring not another instance. So you're going to put a limit on how many containers can run on a node, and then you can bring another node if necessary. So you're going to scale horizontally versus scaling vertically. So vertically means I'm going to give more memory and more CPU, which is what we used to do in VMs, right? So if your VM is underperforming, what do? You give the VM more memory. You give the VM more CPU. It's hard to take back, but it's easier to add. And then you scale vertically. With containers, you can scale horizontally, but then the benefit of that is because you keep adding nodes and each of those nodes can bring more pods and more containers to run for your application. So you can scale, match the requests. When it goes away, you bring it back, and you can do this manually, or you can do this automatically with Azure, checking the load and just adding more instances for you.
Yeah, that's a very important point. And actually, there was like a kind of success story about that like few years ago, or many years ago. I don't know, because if I add 2 years COVID, maybe it's more years than I think. But it was like a company, I don't remember which one now, but a company did like horizontal scaling during the Super Bowl because they had an ad and they knew that it will get like millions of people once they would see the ads, and they didn't add the infrastructure to do so. So they went to Azure, I think. I'll say Azure because it's nice, but they went to Azure, and then it just scaled up just like that. They prepared it, of course. They prepared, they knew, but then it was like they could like take the load and then they scaled down. And one of the points is like what you were saying, like vertical scaling is quite nice. Been there, done that, but then you have to stop the host. It means that you have like a time to ensure that the application or the users cannot use it. So you can just go into outage mode and then pray that it comes up, right? Because CPU changes, it's not that trivial, right? You're not changing your CPU on your desktop under your desk. And then like there's a lot of things here. And the outage, like containers, what they did bring or remove, I would say, of the operation, especially if you have your orchestrator and everything, is like the outage. Like there's outages, but they are potentially transparent. If done well, they are transparent to the end user, not to you because you have to plan it, right? But the end user, they won't even know there was something happening somewhere.
Yeah. And there's a funny story. So we talked about Forza, right? So when Forza launched, they held like millions of users concurrently, like literally millions of users were running Forza 5 at the launch of Forza 5, which I believe was during the holiday season, by the way. And there's a inside story that Tyler told me, the one of the senior developers or the principal developers for Turn 10 Studios, that the moment it launched, they were going to have lunch because they knew the auto scale was there and they didn't have to worry about it, right? And I mean, that's a case where they didn't change the code of the application. They only moved the application to Kubernetes and Windows containers, right? And then they set up the auto scale. They set up everything that they had to. They did some test loading tests on the platform. And at the moment of launch, they were like, yeah, there's nothing to do. Customers are just gonna use, and we can go have lunch.
That's brave.
I'm not entirely sure if they actually went out and had lunch, or if it was more like him trying to say like how confident they were in the platform.
Yeah, Vinicius, I wanted to ask you about Windows Server 2022 and some of the new features around Windows Container. What's new? Some of the improvements and features that we have in 2022.
Yeah, great question. And I'm saying great question because we did not plan this before. Saying great question when you plan before is not great. So I did a blog post before the launch of 2022 last year that basically described the new things that were coming up. I'll try to remember some of them. So there were like 3 or 4 related to networking. So networking had saw a lot of new features in 2022. One of them was support to IPv6 or dual stack, I should say. Like you can't run IPv6 only, but you can run like IPv4 and IPv6. So that's an option. There were 2 other things about networking. One the customers were asking for a long time was host process containers, and not exactly that. So one of the things you can do with Linux containers that there was no feature parity for Windows containers was something called privileged containers. And privileged containers is basically a way for you to start a container on a host, and then that container has the ability to change stuff on the host. So think about, you have to install something on a container host. You just bring a container, the container will run, install whatever it has to do on the host, and then you delete the container. So that's what a privileged container is usually used for. And Windows never had an option for that. So there's a lot of third-party plugins and ISVs that wanted to use something like that for Windows containers, and they never had an option. And with host process containers, now they have this option of running a container that has the privilege of changing something in the host. It's not exactly the same implementation. It actually doesn't work on Docker, which is a whole different conversation about container runtimes. It only works on containerd. But if you're running on Kubernetes, you should be able to leverage host process containers for Windows Server 2022. And there's more. I just don't remember on the top of mind exactly what those things are. But there's a blog post out on what's new for 2022.
Yeah, the host process, that's my next playground, I would say. So you will hear from me.
That's a big one, Vinicius, and I think that's going to help us to do like something called teleport. That's like copying, like on AKS, we just caching images on the host, because the image, like I said, 5 gig. Even if Docker image, we have layers, you can cache.
Yeah.
Not like reloading this thing, but help you to have like a privileged container to do that job for you if you things like that. And
teleport was
very handy.
For a long time. Teleport was an internal thing only, so I never know how much can be shared or not. But I think it's out. Teleport is a way for the host to actually map the container layers via the network stack. And one of the things for AKS is that actually all the Windows-based images are present in an AKS image. So if you run a server core image, the layers of the server core images are already cached on a Kubernetes, on a Windows node on AKS. So if you run a simple server core image, it's instant because the layers are already there.
Yeah, and that will allow other distributions to do the same, and using Kubernetes and Windows nodes, they're going to be able to do the same. What's going to be nice as well.
Yeah.
And the sky's the limit. I think you can do now things that people used to do on Linux, and now you can do on Windows as well.
Yeah, I mean, it is an established platform. We have a lot of customers using the latest internal customer that we showcased in our customer story website is Office 365. So they are replatforming everything on Windows containers and Linux containers. All the new stuff that they're developing is based on Linux as well, but to run on AKS. So that means there will be a lot of Office services teams that run their services separately. They're going to run on AKS. And the main platform that is going to do that, because they're developing on Windows pretty much, is Windows containers on AKS. So it's a big project. They are consuming a lot of cores, and they're going to move. So that's just to say, established platform. If you have an IIS environment, those are just 5 reasons that you should consider to move to Windows containers. Every environment is different. Every customer has different requirements, but those 5 things are usually things that we see every customer facing as issues of managing their IIS instances.
So yeah,
that's great.
Yeah,
Nuno, you can ask what's the next step, and I want to ask you as well about Windows containers for the developers.
Okay, quickly. I have one curveball, but I will keep it for the next one. But that's okay. But I still have one last question though. You mentioned like there's the website aka .ms/containers that is like whatever you want to know about Windows containers. But do you have also maybe a resource, maybe on Microsoft Learn, I don't know, about the Windows containers, how to get started, how to understand that?
Yeah. Yes, there's a website called Microsoft Learn. You can just Google or Bing Microsoft Learn, should be the top result there. And it basically is a way for you to learn every Microsoft technology you can think of. If you type Windows containers in there, we have a bunch of resources in there. Probably the main one that is going to show up is Run Containers on Windows Server. That course is still a bit outdated because it was created on 2019, if I remember correctly. I'm at this stage. I actually have the resources here open because I'm working on updating this course. Before this call, I recorded a video of a demo for 2022 that is going to go in there. So it's going to be updated soon, but Microsoft Learn is the main website that I would recommend people to go. And there's a specific course on Windows containers in there.
Yeah, perfect. Thank you.
Yeah, I think that was the main question. And another thing people ask, how can I play on my local environment? If Vinicius or Nuno want to discuss that. Nuno is from SUSE, and a lot of people now using Rancher Desktop. At least I'm using that for Linux. For Windows containers, it's still on Docker Desktop locally if you want to use Windows containers. Don't have host process there.
Yeah, exactly.
If you want to go ahead on.
Yeah, so I will answer unofficially for SUSE because I'm not part of the team of Rancher Desktop. So there's two things, like Rancher Desktop itself. So if you are a developer, you use Rancher Desktop. Thank you. And it's still not at the time, right? It's not yet using Windows containers as an endpoint, let's say. Now, that being said, we do have, let's say, our production ready main Kubernetes distribution, so the container orchestrator named RKE2. And that one, you can easily spin up actually a worker of a Windows node and run your Windows workloads containers right there. So that is working nowadays. You can install it also on your local machine. That's not really meant for, I would say. RK is really, let's say, production grade Kubernetes. So it might be a little bit, it's not that heavy because now it's based also in K3S, our other distribution, but K3S itself has not a worker node compatibility right now. Being fair play and being in the cloud native, I would say that our friends at Mirantis are running K0S also. Again, it's Kubernetes based, and they have in beta, I think now, at the time was alpha, but I think now it should be beta. They have also the worker node deployment. So you have two choices nowadays, both RKE2 production and Windows is I would say almost first citizen right now. So you can, I mean, it's part of the deployments, it's part of our docs, you can deploy it. K0S, they are working on it. Other, maybe they are also doing it, but I'm not aware. And
yeah,
of course,
specifically, sorry, go ahead.
No, yeah, just to end up because you can see the sign here. Docker Desktop runs containers on Windows just like that. You just have to swap the runtime to be Windows containers, and it just works. And actually, I wrote blog posts long time ago, 2015, 16, how to run both Linux and Windows. It's not meant to, but you can if you want. So, but yeah, so Docker Desktop, definitively if you want to try out the Windows containers. And like we were discussing with Vinicius just before, the website, so aka.ms/containers, there's a part where now the installation on, let's say, the server side is way easier than before. Okay, so way easier. We have the three options. I will try out containerd option with the host process, of course, but yeah, but that's it. Yeah.
Yeah. So the three options Nuno was saying is you can install Docker CE/Moby, which is the open source project from which Docker builds their commercial products. And so that's one option. You have the Mirantis container runtime as well as an option in there, and containerd. Those are three different container runtimes /CLIs that you have. And Microsoft created a specific script for each one of those. So you just run the script and everything is installed for you through those scripts.
That's going to be on the documentation as well.
Yeah, aka.ms/containers. There's an option there to prepare your container host. And then there's instructions for Windows 10 and 11 and Windows Server.
Yeah, that's great. That's great. Yeah, and remember the Docker Desktop, if you are using Docker Desktop, it's just like a single container. You're not going to have a Kubernetes cluster. When you enable the Kubernetes clusters on Docker Desktop, there is no Windows nodes or workers there. It's just Linux. Means that, yeah, you cannot use a Windows nodes, Kubernetes with Docker Desktop, just single normal Docker containers.
Yep.
Exactly. It was really about containers. That's why I spoke about RK2, K0S, it's the Kubernetes side, and Docker Desktop will be the container side only. Still, Vinicius mentioned very fast because the project is there, but we don't know. But there's the Docker Swarm also, and Docker Swarm, because it's containers, works also with Windows containers. So you can have a sort of scaling with Docker Swarm if you want really to play with it with Windows containers. But yeah.
That's nice. Any final comment there, or anyone want to bring something for Vinicius, or last question? If not,
I just wanted, from my view, I guess it was a great insight because as I mentioned in the beginning, most of the customers, when they think about containers, always Linux. But now we have some ideas and some scenarios where it would make more sense to have a Windows containers. I love the lift and shift idea, the MSI, the tools that are familiar for an existing Windows IT Pro, and all the benefits that you get with Windows containers in some particular examples changed my mind on how to think about containers from a Windows perspective. So yeah, it was good insight. Thanks for that, Vinicius.
Yeah, absolutely.
Yeah, and that's the main reason, if you are watching these and just keep in touch. Vinicius is doing like amazing content. He's now like a cloud developer advocate for Windows containers. He's not a program manager anymore, but I'm sure that he can keep helping a little bit on that side as well. And thanks, Nuno, again for coming and I know that's very late for you, more than 1 a.m. there.
That's
and
okay.
Thanks a lot for being here, and welcome, Leandro, as well. Thank you, guys. Thank you so much.
Thank you.
Appreciate
Thanks,
it.
folks.
Bye-bye.
See ya.